So we are looking at a Tempstar heat pump and low voltage short situation. Of course, they didn't install the secondary transformer when they put this in, so it's taken the whole load off of the unit transformer, but I don't think that'll blow a fuse. I was here the other day, Thursday last week, and as you can see, there's a wire nut right there because I guess since the day it had been installed, this wire, which comes off the float switch, was pinched right in this door. Turned it on after replacing the fuse, ran it through heating and cooling, auxiliary heat pump, reversing valve shift, all that jazz. Everything worked, and they called back again today, and then the fuse is blown. So let's get the door off of here. So I'm going to put a fuse in it, and then I'm going to use these wires up here on the zone board to energize all the low voltage circuits in it. And it could be something to do with the zoning, I don't know. We'll do some inspections of our wire and stuff and make sure nothing's pinched or cut. But there's our popped fuse. So I'm gonna go through and inspect these wires right in here first, because these things, I hate these cabinets with this little metal thing in here. At least they didn't try to cram all those back in there like you usually see. But we may have a rub or something somewhere. It could be something in one of the damper motor wires shorted. I don't know. There's a staple, right? Here we go. Didn't see that the other day. Let me see if I can get you some light on that. Just happened to see that piece of copper right there. Nice and shiny. I don't know if you can see it. It's going to be right at the top right there. See that black thermostat wire? Copper skin. See if I can get it to reflect right there. Oh, be goodness. I didn't even look at that the other day. Maybe that's what it is. I just don't know how well you can see that. And if you look just to the left of that red wire, there's the black thermostat wire. Alright, so I've got a fuse back in there. I separated those wires over there. Some of those were unused. They're just going to the damper motors. And I believe one of the ones that was skint wasn't even used. So got that straightened out. Got a fuse in. I'm going to check my amp draw on my low voltage R coming off the transformer as I go through here and energize these. This is the equipment side, that's the thermostat side. I have the thermostats disconnected. So what I'm going to do, and they used blue right there for my R, and the button's missing right there. Go figure. You gotta be kidding me. Let me see if I have something that'll go in there. And let me see if I can get this wire. I don't know how far this thing goes back in there. I can't get the button down to release my wire. So let me see if I can pull one of these unused and get it to go in there and release my button. There we go. There we go. Alright, so we're going to use I'm going to energize each one of these, and I just want to see what my load is on that transformer as I energize each one of these circuits. So we'll get the disconnect put in. Purge mode. And what I'm going to do is I'm going to energize the blower first. And I'm using my little short pro tool here. So I'm going to use this. So the first thing I'm going to do is energize the blower. Let's see what my amp draw is. With the blower energized, no light. Blower's on. And minimal amp draw, 0 actually. On that. So now we're going to energize the heat strips. Still not getting my load on my R there. Hold on. Get this wire nuts loose. Yep. That's not going to cause a short. I'll tighten that up in a minute. See what my amp draw is. Right now it's just a blower. So you can see that wire popping out behind that wire nut right there. You hear it click when I turn that. I'll fix that in a minute, but that's not going to cause a short. It's just going to cause the heat strips not to run. Back up here on my R. And let's energize the outdoor reversing valve. There. Now we're getting something. We got a coil on that valve. So we're at 0.4 amps on the reversing valve solenoid. Let's get the contactor on. And that'll be the last load. Now we're up to 0.75 amps, so that's not going to pop a 3 amp fuse. So everything is energized right there back to the equipment. The only thing out of the circuit is going to be, I'm going to shut the outdoor unit off because I've got the door for the blower off. There's the thermostats. So I think I probably am going to go through and energize back through these thermostats one at a time and see if our short might be on the thermostat side of this thing. And once again right here, I have everything jumped out. And outdoor unit, auxiliary heat, reversing valve right there. And everything is running. Outdoor unit is on. Heat strips are on. Blower's running. So let's put the thermostats on and see what happens. Alright guys, next I'm going to energize these damper motors real quick. See what kind of amp draw I get on each one of those. Now keep in mind this is just 2 zones. So typically you're only going to have one of these closed at a time. So we will do this one first. And it is closing. And we are getting a 0.5 amp on that. Make sure it closes all the way, and then we're going to do the other one. Watch that, make sure that amp draw holds, doesn't start spiking. Alright, now we're going to do the other one. Which is over there. You should see our little red light at some point come on over there. I'm not going to get all the way over there. Make sure that one is closed. That one does seem to close a little easier than this one does without all the racket. Closed a little faster as well. Also 0.5 amps. So I'm going to say good, but that one sounded a little boogery. But it is closing and our amp draws good. To combine those would be 1 amp, but 2-zone system, only one's going to close at a time. So let's get this thing turned on. Alright guys, now we're outside. I've got this thing running and cooling. It's been on probably about 10 minutes now. I got it turned down to 65 degrees. It's about 63 outside right now. So what I'm going to do is, so I don't have to go back in the house, I mean everything in the house is energized. G, Y, and O are energized. I've jumped out auxiliary from up there and tested that circuit and everything worked fine. I want to test the defrost cycle on this thing, and it's 63 degrees out here. So what I'm going to do pull the disconnect out. So this in this unit is your defrost switch, and one thing you can do is you could come up here and disconnect the fan if you wanted to test it as it operates, then turn this thing back on and heat. I'm going to disconnect O instead of going back in inside. So I'm going to unplug the power from the board so it'll kind of reset. I'm going to disconnect O, and then I'm going to power it back up without that call. So the defrost board thinks we're basically in a call for heat. Band-aids ain't what the shit. Anyway, so, and I'm going to jump out. I mean, like I said, you could just disconnect your fan speed and then just let this thing run until this coil starts to frost. If you want to test the switch to see if it closes like it's supposed to, you can just sit there, put your meter on it and wait and see if it starts to ring through on continuity once the coil gets cold enough. But I don't have a problem with that, because all the wires, those wires are not rubbing that I can see. I made, yeah, those pink wires are going straight to the back of that defrost sensor. They're not rubbing against anything. Maybe I'll check that one little place right there, but the pressure switches are not rubbing against any copper or anything like that. So I don't think I have a wire rub in this thing. But just to speed up the process, I'm just going to jump out my defrost switch and test it that way. Alright, there. So I'm going to jump that out, trick it, basically, hopefully, maybe, we'll see. Contactor's pulled in. I'm gonna turn this thing back on in heat. Let it run for a few minutes. Let this thing kind of time in, and then we'll do a defrost test and see if everything stays on. So we're gonna let it run in heat a minute. And like I said, the thermostat wiring out here, we need to check down inside this Romex connector. Make sure nothing's rubbing in there intermittently. But it's in liquid tight and it feeds right up inside there. So there's nothing rubbed or hit with a lawnmower. There's a set of rotors, I guess, or something. The guy's got tires stacked out here. But I'm suspecting either this defrost board or that zone board up there. So if the defrost test works and everything in there checks out clean, even if I find something in there I need to straighten up, I'm going to do it. But what I'm going to do is I'm going to bypass that defrost board. I'm going to run it on our upstairs thermostat for a couple of days and see if it goes. And if it runs with the zone board out of the circuit, then it could possibly be that zone board, because that's the only outlier. If this works and I don't find anything in there that gives me concrete, yeah, I'm pretty positive. I mean, that's plastic actually. It's just got this metal ring around it. Tighten it. But this is plastic. So I don't suspect I'm going to find anything in there. So if this thing defrosts like it's supposed to, and that defrost box doesn't maybe back short on the auxiliary heat side when it energizes the heat strips, which is the only thing I haven't checked at this point, wire the system to the upstairs thermostat, let it run for a few days. If it's still working after a few days, we'll recommend replacing that zone board, because all the low voltage connections from everything come to a head right there at that zone board. Real quick for the Supertex. I did this when I was here last time, but let me go ahead and show you that I did check the contactor. And we're at 16 on the contactor. And we are at, hold on, let me get my needle leads in there, my probes in there. 15 on the reversing valve solenoid. Alright, so I've got my meter set around my W2, which goes back in for the heat strips. I want to see if I get a spike in my amp draw when this zone board energizes that feed. So let's see if we can get this thing to go into a defrost cycle. I'm not getting a spike on anything there. Let's check my R. .5, but that's probably going to be related somewhat to that's going to be related to our reversing valve being energized, I'm guessing, maybe. Yeah, so it's energizing the reversing valve on another circuit, which is over here. Yep, there we are. So it's sending it that way. It's not coming in through here. So I don't think we have a defrost board problem either. I think it's going to be that zone board up there. So I'm going to bypass the zone board, hook it up to our upstairs thermostat, let it run for a few days and see what happens. If it works, then we'll quote her a new zone board. Anyway guys, appreciate you watching. Like, subscribe, and have a good one.